Have you ever wondered how an oscilloscope works? How it captures and displays voltage signals, allowing us to see electrical signals as they change over time? Well, today is your lucky day, as we're diving deep into the fascinating world of oscilloscopes. First, it's important to understand what an oscilloscope is. Think of it as a graphical representation of electrical signals. It's a device that draws a graph of an electrical signal. In most applications, the graph shows how signals change over time. The vertical y-axis represents voltage and the horizontal x-axis represents time. Now imagine you have an oscilloscope in front of you. The first step you need to take is to power it on. Give it a few moments to warm up and stabilize. This is important as it allows the internal components to reach their operational temperature and provide accurate readings. Once it's warmed up, set the oscilloscope to display the input signal. This involves adjusting the vertical and horizontal scales to suitable levels. The vertical scale, controlled by the volts per division knob, adjusts the amplitude of the signal, while the horizontal scale, controlled by the seconds per division knob, adjusts the time base or sweep speed. Next, connect the probe. The probe is a special type of wire that carries the signal from the device under test to the oscilloscope. Carefully attach the probe to the circuit point you want to measure, ensuring a good connection. Now the signal should be visible on the oscilloscope screen. However, it might not be stable or it might be off the screen. To stabilize the signal, use the trigger controls. The trigger tells the oscilloscope when to start the sweep. Adjust the trigger level until the waveform stands still on the screen. If the signal isn't visible, adjust the vertical position control until it comes into view. And if the signal is too big or too small to see clearly, adjust the volts per division setting again. Finally, analyze the signal. Look at its shape, frequency, amplitude, and any irregularities it might have. These characteristics can tell you a lot about the electrical behavior of the device you're testing. So, to summarize, 1. Power on the oscilloscope and let it warm up. 1. Set the vertical and horizontal scales to display the input signal. 1. Connect the probe to the circuit point you want to measure. 1. Stabilize the signal using the trigger controls. 1. Adjust the vertical position and the volts per division setting if necessary. 6. Analyze the signal, and there you have it. You've just learned how to use an oscilloscope. It may seem daunting at first, but with practice, using an oscilloscope can become second nature. Remember, the key to mastering any tool is understanding how it works and getting hands-on experience. So don't be afraid to roll up your sleeves and dive in.